Namaste students, welcome you all in the next class of the periodic classification of elements. Let us see the Mendeleev's classification. Okay, Mendeleev's periodic table. What is there in the Mendeleev's periodic table? Mendeleev's periodic table based on the physical and the chemical properties of elements and their atomic masses. Okay, as per this basis of the classification, he gave the law of the classification, which is known as Mendeleev's periodic law. Mendeleev's periodic law. According to this law, he told that the physical and the chemical properties of the elements are the periodic function of their atomic masses. It means when we go in the periodic table from left to right in the increasing order of the atomic masses, then there is a periodicity. There is a repetition of the same properties, whether chemical or physical properties, after a certain interval of time. That is the meaning of periodic function. Means there is a periodicity, there is a repetition of the chemical and the physical properties when arrange the elements in the increasing order of their atomic masses in the periodic table. That is called Mendeleev's periodic law. Okay. Now come to the next point. Periodicity. What is the periodicity? As I told you, the repetition of properties of elements after certain regular intervals is known as periodicity. It is called periodicity. Clear? Periodicity means there is a repetition of the same kind of the chemical properties after a regular interval of time. That is called the periodicity. This question is asked many times. Okay, in the board examination, that what is called the periodicity of the properties. So we can say repetition of the properties of elements after certain regular intervals when we are arranging them in the increasing order of their atomic masses. Okay, this is known as periodicity of the properties of the elements. Okay, next come, what are the merits of the Mendeleev's periodic table? What are the merits? Merits means achievements. Okay, Mendeleev's left vacant places in his periodic table which provided an idea for the discovery of new elements. Example, he told, and he gave, rather we can say he gave the name Eka boron, Eka aluminium and Eka silicon. Okay, Eka boron means before the boron, Eka aluminium is before the aluminium, and Eka silicon means before the silicon. He left some gaps. In those gaps later on when discovery was made, then exactly in the same place with the same chemical and physical properties, they were able to arrange the elements discovered after certain interval of time. So Mendeleev's periodic table was predicted the properties of several undiscovered elements. Okay, on the basis of their position in Mendeleev's periodic table. It is useful in the correcting the doubtful atomic masses of some elements. Some elements were having the doubtful atomic masses, so those atomic masses were corrected on the basis of the gaps which were left by the Mendeleev in his periodic table. Noble gases could accommodate. Noble gases could have been placed in the right place, okay, in the Mendeleev's periodic table without disturbing the periodic table after discovery. At that time when he gave this periodic law or the periodic table based on his discovery, then at that time these noble gases were not known to us. But later on when these noble gases were discovered, without disturbing the existing periodic table given by Mendeleev, those inert gases were kept in the last column. Okay, understand? So this was the achievement of the Mendeleev which was discovered by him. Understand? Next is, what are the drawbacks? Number 1, no fixed position. No fixed position for the hydrogen. There was no place provided by the Mendeleev in his periodic table that where hydrogen has to be kept. Okay. So no fixed position for hydrogen, no correct position for the hydrogen atom was in Mendeleev's periodic table. Example, position of hydrogen with alkali, metal and halogens. Halogens means the elements belonging to the 17th group. We will discuss later on. Okay, where is the 17th groups in the modern periodic table? And second is no place for isotopes. As there were, suppose hydrogen is 1H1. It has the isotope with the atomic number 1 but the mass number 2. It has 1H3 also. Oxygen also, oxygen's 8, okay, oxygen atomic number 8, 16, okay, 8 O 17. Okay, so there are the isotopes of oxygen, nitrogen as well as the hydrogen also. So these are the atoms of the same element, but there is no place provided for the isotope like 1H2 and 1H3. Chlorine also, chlorine 17, 36, 17, chlorine 37. Okay, these are isotopes of chlorine, but there is no place for the isotopes of chlorine, isotopes of oxygen, isotopes of hydrogen. Okay, this was the drawback, that the atoms of same element, he never gave any idea about them, that where they have to be kept. Actually these are the atoms of same element, so they should be given the same place in the periodic table in the same group, but there was no provision made by the Mendeleev in his periodic table. Okay, now come to the next point. No regular trends in atomic masses. Position of some elements with lower atomic masses before with higher atomic masses. Example, nickel. If you see the Mendeleev's periodic table, it is given in the group number 8. Group number 8 at last. Okay, it is given group number 8. Here he has kept the iron and he has kept cobalt as well as nickel. 3 elements. Iron has 55.8. 55.8 is the atomic mass. Cobalt is having 58.9 and nickel is having 58.7. Okay, so 58.7 is the atomic mass of the nickel and 58.9 is the atomic mass of cobalt. But cobalt is having the higher atomic mass, then also he has kept cobalt first and nickel later on. Means he is not obeying his own law which is given by him. He told that elements are kept in the increasing order of their atomic masses. So here increasing order of the atomic masses is not followed. First the element with the higher atomic mass and after that element with the lower atomic mass, that is 58.7 of the nickel. Okay, so this is another drawback found in the Mendeleev's periodic table. Understand, students? Clearly it is mentioned here. Okay, this nickel 58.7 and cobalt 58.9. It should come first. Okay, who should come first? Nickel is having 58.7 and cobalt is having 58.9, but cobalt has come first and nickel is kept later on. Means there is a no order of the increasing order of atomic masses. This is the major drawback found in the table of the Mendeleev's. Let us see here the Mendeleev's periodic table which is given in the book also. All can go through it. See, it is based on the hydrides of the elements and the oxide of the element. R2O. R2O means metallic oxide. RH means metal hydride. Suppose hydrogen 1.008 atomic mass, lithium 6.938, then sodium, then potassium. Okay, rubidium, cesium and francium. Okay, so here what is the procedure he has followed? Based on the oxide and the hydride produced by the element, he has made the classification of the elements. R2O means first element H. So what will be oxide? H2O. Clear? Let me tell you in the separate slide, that will be better. And you will be able to understand. Suppose here R2O is the general formula, R2O. Based on this R2O, what is the oxide? Hydrogen H2O, lithium, so lithium Li2O, and after that sodium is there, sodium Na2O, then copper Cu2O, okay, Ag2O, understand, rubidium Rb2O, next is gold Au2O, 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 clear. So here these oxide with the same general formula which is given in the periodic table of the Mendeleev, he has given that idea that if they are making the same kind of oxide, Au2O, copper oxide, Ag2O, rubidium oxide, if such type of oxides are produced, then they can be kept in the same group. Based on the hydride, suppose RH, okay, then LiH, okay, it is following the general formula of RHLi. L means the metal element and its oxide, hydride. So lithium hydride. Similarly, another is sodium hydride, NaH. Next element in the periodic table of the Mendeleev is sodium. So sodium hydride, then potassium hydride, KH. After that coming CuH, copper hydride. Okay, copper hydride. Then comes rubidium hydride, RbH. Next is AgH. Okay, if these type of oxide are produced by the elements following the general formula RH, then these elements will be placed in the first group. Okay, understand, students? I think it may be clear. Go through this periodic table given by the Mendeleev, so it will be clear to you. Similarly, come here in the second group. Okay, RO and RS2. RO and RS2. General formula is RO for the elements placed in the second group. So RO means R is the metal or element, you can say. So BeO, then MgO, CaO, ZnO, SrO, CdO, BaO, HgO. All these elements placed in this group of the Mendeleev's periodic table, they are making the same kind of the oxides. Okay, after that we can talk about the hydrides. Let us see second group. Okay, RO is the general formula. Then here RO means R is the metal. What is the metal present here? Be, BeO. After that MgO. Then next is Zn, so ZnO. Calcium, so CaO. Then strontium, so SrO. Then Cd, then CdO. Then BaO. After that lastly it is coming mercury, so HgO. All these elements present in the second group, they are making the same kind of the oxides. Okay, so they are kept in the same group following the general formula RO for the oxides. Okay, students. Now we can talk about the hydrides following the general formula RH2. So R is the element. R is the element. So BeH2. Okay. Then Mg. So MgH2. Next is calcium. So calcium hydride, CaH2. CaH2. Alright. Next is Zn. So ZnH2. Okay. Next is strontium, SrH2. Then comes cadmium, CdH2. Similarly, barium, so BaH2. Next is mercury, so HgH2. These are the hydrides. Okay, if such type of hydrides are produced by the elements, then they will be coming in the same group because they are following the general formula RH2. Clear, I think? So this is about the second group which was given by the Mendeleev in his periodic table. So on the basis of the general formula, these all the groups were created by the Mendeleev. R2O3, so here see B2O3, Al2O3, SCO3, Ga2O3, then Y2O3, In2O3, then La2O3, then titanium, so Ti2O3, following the same kind of the oxides. Similarly here, hydrides also following the general formula, RH3, BH3, AlS3, SCS3, GaS3, vanadium, so YH3. After that, indium, InH3, lawrencium, RaH3, titanium, TiS3. Okay, so for this third group. Similarly for these also, all the 8 groups are based on the same kind of hydrides and the oxides. Here after the third period you see RO2. Here R, here O2. Just pattern is change. Here R2 is there, but here O2 is there. RO2. After that, here R2, O5 increase by 2. Here 2, here increase by 2. Okay. See, let me see, tell you again. Here RO. So here RO2 increase by 1 in the oxygen. R2O3 increase by 2. Then here RO3. So here RO3. Okay. Then R2O7. R2O7, 3, then 2. Then 7. Understand? Here R2O, RO, then R2O3. Here from, if you see, there is an increase by 1. RO, then RO2, R2O3, then R2O5. Okay? Then RO2, then RO3, then R2O5, then R2O7. After that, RO3, so RO4. Okay? In one column, increase by 1. In the second column, increase by 2 in the oxygen. In that way, we can learn the trick to learn this pattern, how it is followed in the Mendeleev's periodic table. Okay? We'll meet in the another class, students. Okay? Thank you.